Okay, well, I have 3:30, so guess that's all the setup I'm going to be able to get done today. So the premise of this is I am let me take off that desktop preview since we don't care about it right now. So I'm M. Schaefer 1. I am the primary author on FRC LabViewTutorials.com. I have been hosting in-person workshops for the last couple of years at a kickoff in Searcy, Arkansas. This year, with FRC not being able to do live events, at least not yet, that did not happen, and as such I did not get invited. And I thought, well, maybe instead of doing that, I would live stream a single session, because I've been doing 2 sessions, but the intro session is the same every year, so you can actually go watch a recording of that here on the same channel. But let's go ahead and dig right in. So I'm going to switch this. Let's see, I want to go ahead and minimize that. And unfortunately, because of my current setup with Windows, I don't have the ability to both preview and the slides at the same time. But let's see how this goes. So if we go to the desktop and then we start the slides. Okay, so these slides are available up on workshop.frclabviewtutorials.com, as well as slides from previous years and links to the recordings from previous years. One of the things I wanted to touch on was customizing the dashboard, and then I watched the game animation today and realized that they're not really planning on using the dashboard, at least not initially, so I'm actually going to just breeze through this part. And if you have any questions, throw them in the chat and I'll try to answer them. But to customize the dashboard, you want to open up a project, and if I switch to my desktop and come up here, and I'm just waiting for the preview to confirm that that did work correctly. That may not have worked. Yep, nope, that did not work. I want you to switch to that one. Yes, there we go. Okay, so we want to use the FRC dashboard project. And this isn't 2020 anymore, so I'm going to make it 2021. Default location's fine. You can choose any of these dashboards, but if you start with just the dashboard, that will be the default dashboard. Click Finish, and this will create a project for you. And the setup of this project starts with the dashboard main, and then it's got a couple of additional files. And I'll talk about just briefly how to add more controls to the dashboard, how to send data back and forth from the robot, and how to have your driver station actually open your modified dashboard. So I'm going to open dashboard main, and yeah, it's okay for this to open up ports on my network. It's loading projects. Lots of VIs, lots of functionality baked into this. And here we have the default dashboard. And I'm going to hit Control E to switch to the backside code. And pretty much you don't want to alter the provided code. In fact, there's this big bar here, so the remainder of this code shouldn't need to be modified. Situations where you might want to modify this existing stuff, this image control here, there are, if I remember right, yeah, camera, properties, nope, not there. I want to use the fact that this palette's right away available. So that's to add overlays to it, or if I use the iMac image processing palette, I can go in here and do a rotate image. This is particularly useful, which I'm not actually seeing. Oh, I know it's in here. Dispose, do an image, offset, do. Where's the rotate? Okay, I'm just going to do a control search for iMac rotate. There we go. And this will allow me to, I could pipe through here and then back out, and I could tell it, hey, I want you to rotate it 180 degrees because my camera is mounted upside down. So that might be an example to do it. Actually, I'm going to go ahead and finish it, right, because you want to display your rotated image. And now my camera's flipped over. That might be an example of a reason to customize your dashboards, to do that on the controller side rather than on your Robo for a little less, save a little bit of RAM and processing for that. You could also add controls, like for instance, if I wanted to, say maybe on this custom tab, add a button that says stay still, and if this is true, then the robot doesn't do anything. If it's false, then I want it to actually go and do stuff. So I just want to send this information to the robot. This top loop receives various data streams from driver station, update joysticks, motors, etc. This is how it displays the joystick positions and what the drive motors are doing normally. We're going to just add to that and say, hey, in addition to receiving some data, we're going to use a WPI library, dashboard, and we want to write a value to the network table. Let's name this auto off. And for the value I want to write, I'm going to take my stay still, and I'm going to pass it in here. And so that's going to send an auto off that I can read on the robot side of things that says, hey, I don't actually want you to move anywhere. Similarly, if you want to display the gyro, you have to send it on the robot side somehow, maybe call it gyro. And that's actually a number. So you could do this on the robot. I'm going to just put that in a frame and label it as such. On robot. And of course, on a regular cadence and using your actual gyro value, but then on the driver station dashboard, you want to read that value, and it is a number. Pipe it into the gyro, and name it the same thing, and it is case sensitive, so just make sure it's the same thing. So this on the robot, publishing data, this here, and that actually causes your gyro display to update correctly. And that's an example of how you would modify the driver station if you wanted. You can add stuff onto the custom tab. You can actually mess with a lot of this, but be careful. Sometimes having these handy makes it easier to debug when stuff goes wrong. And again, if you have any questions, just pop them in the chat, and as soon as I see them, I will try to answer them. And if you're watching this later, you can try to ping me via mshifter1 on Chief Delphi, or post a question on Chief Delphi in general. A lot of people are on there, and a lot of people will help, which is great. As far as building this dashboard and making it be used, one thing you can do is you can actually open it up and you can run it, which is also Control R. And yes, it's okay if it accesses my network, and because I'm not actually actively on a team right now, I'm just doing this, I have to say I want to evaluate. And I don't have a camera currently connected, but then once that's open, I can open the driver station, and yes, that's okay. And yes, private networks. And did that switch me up? So even, because it was already open and running, when I opened the driver station, it went straight to, oh, nope, it decided to, okay. Yep, we are evaluating. Okay, that kind of looks like we're back up. Confirmation we got audio here. So move this. It should show up there. Yeah, sorry about that, folks. My internet just died on me. The stream died. My streaming computer froze up, and it looks like we're back up. Hopefully that doesn't happen again. Yeah, so with the driver station open, I was able to say I wanted to use the LabVIEW dashboard, and I started using this one. And that all works hunky-dory. I'm going to go ahead and save that. If you wanted to build it to use the executable copy, which will actually run slightly faster because you're not running the debug session, then you can do that, and it opens up and compiles it down to an exe, which you can. This is actually an error. Uses VIs from Vision Development, which is currently in evaluation mode. Okay, you have to license before you can do it. But you can license using the license key provided in your kit of parts. I just haven't done that because, like I said, I am doing this as an individual, not actively with a team this year. Sure, we'll save changes. And if we hop back over here and look at, and skip past that, I have a set of sensors here that I wanted to walk through demoing how to use. It would just be nice if I had a better way of showing the slides. Yeah, I might be able to do this. I'm going to take advantage of the fact that the slides are online and just go download them and open up in the software I have on my primary computer. There we go. Yeah, that will allow me better control while simultaneously stepping through. Okay, so I've got a couple of sensors here with me that I could demo using. And again, if you have any questions, just throw them in the chat. So one of the sensors that you can use is an encoder. This is whether rotational speed or position, but doesn't know position once at power up. So it's great for measuring speed, say, of a shooter wheel or a flywheel, trying to measure rotational distances possibly greater than 8, but not really great when you don't care about when you do care about your starting position. So good places to use this are your drivetrain because of the sheer number of rotations you'll go through, even in demonstrating the game changers at home, and on a flywheel or wheeled shooters to allow for more accurate aiming by dialing in that wheel speed. And the basic setup is you use the WPI library to open an encoder, call a get, and that gives you both the distance from the starting point. If it's an incremental, so there's two different types of encoders. There's an absolute encoder and there's an incremental encoder. In absolute count up and down, they require 4 channels, and so that gives you absolute position from starting point, and then there's incremental where they only count one way. Regardless of which direction the wheel is going, it's going to count up. And I'm getting information that it's not getting enough data. So we're going to stop and restart, I guess. Okay, well, hopefully the stream stays live. And then reading it, so this is using the typedef setup where, so I've created it and I'm using the get. I can pass out the rate into a PID, and I'll touch more on what a PID does later. And say I want it to spin at 1200 RPM directly, so it would be 1200 ticks per minute, depending on your encoder. That may be more or less equivalent to an RPM. And based on that, I want to set the motor to it. PID allows me to do what's called closed loop control, and I will touch more on that later. You can also view the last 2 recordings of the Advanced LabVIEW webinars. They touch on in detail. And I do actually have one here with me, so I'm going to open up LabVIEW. I run a RoboRio project. And again, this is 2021. I'm going to use 3288. That is the team that I'm an alumnus of. Arcade drive is fine. Finish. Yes, I want to overwrite the project because that's what I was using for demo purposes. That's about it. So I actually have a RoboRio here with me. And I've just got power and USB plugged into it, but I've also got an encoder. Now this encoder, I got it out of an Arduino kit and I put a volume knob on it. So you probably, yeah, I don't think you can hear that clicking, but like it clicks every distance and rather than being very fast. But it is a absolute encoder, so it takes what's called the clock and the data, which are actually, there's clock, data, switch, positive, and ground. The positive powers the sensors on board, the ground provides comparison, and then the clock, data, and switch are used to accurately measure rotation up or down. So I'm going to plug this into my DIO. I want ground and positive to go such that they're going into the ground and voltage on the RoboRio here. So I'm going to plug this in, and I'm going to use DIO 0. Let's plug this in here. And then I've actually connected my clock and DT to being on I know what that is. Okay, SW is this also has a physical switch in it. So I really want the DT, which is yellow. So I'm going to plug in the yellow so that it goes into the next DIO sensor line on DIO 1. So I've got ground 5 volts and the first channel, which is normally labeled A, and then I've got the second channel on the next DIO port on port 1, which is oftentimes labeled B. So I've got those wired up, and since we're at it, I'm going to go ahead and plug that button into DIO 2. And I'm going to go into the tune code, and we actually have this test VI, which is not normally used in the running infrastructure, but just has this, hey, let's open up and run stuff setup. Which includes dashboard reading and writing, and if you were to have the driver station open, would impact stuff. In fact, it is using, what is it? Test, okay, what's the control in? Test mode, test name. It's actually using the dashboard to read it. So, correction, this is meant to be used with the driver station. I just want a clean VI that I can just add some code and have it run. So I'm going to use a control N. I'm going to split the code to using this flat sequence for 2 structures, where we go and begin, and what you want to put in teleop or PR tasks. And so in begin, I want to open up the sensor, and it's down here in the WPI robotics library, and its sensors, I want encoder, WPI encoder open, and it gives me a bunch of example code, which is great. Opening more VIs. And cool. So one thing that happened recently is we started using this digital source concept. So we abstracted away the raw DIO. So you have to use the raw DIO if you want to specify exactly which DIO channel it is, and then you have to convert to a digital source. But this allowed for encoders to be on CAN or things like that, be a little bit nicer. So DIO 0 and 1, that's actually the defaults. I went ahead and named them A channel and B channel. That's great. And then I want to take this, and in my encoder palette I have a ref num set, and I'm going to call this my shooter wheel, because that is what I'm pretending is wired up to sense, and I want to clean up the wire so that it's not hidden behind the VI. So that would go and begin. Because I'm writing this as one VI, I do actually need a wire to go across to make sure that my example of begin happens first, and then what's in teleup happens after. And then again, normally teleup gets looped on its own, so I'm just going to go ahead and put that outside of my simulation teleup loop. And inside here, I just want to read that encoder and display it. You could use it to control any motors, or just to as information in making decisions, but I'm just going to display it. So I'm going to use the, scroll down please, the WPI robotics library, sensors, encoder, and I want the ref num get. And I need the same name I used over here, so shooter wheel. And this is going to give me out the device reference. It is worth noting that since I'm in one VI, I could just wire this straight across, or I could even go from here. I could skip the ref num altogether, but the ref nums are a way of connecting up when you're in different VIs, because they handle, it's a dictionary. It allows you to handle reading and writing and storing and getting that item back easier. If I right-click on the encoder, I get the encoder palette as one of my quick access. That's handy, and I want to just read it. So I'm going to use the get, pass this to here. Now if it errored on trying to figure out what the shooter wheel is, I don't want it to actually do it, so I pass the error wire across. And then for the distance, let's do the distance. We'll create an indicator, and we'll do the same with the rate. Now by default, these indicators are just numbers. With LabVIEW, it's actually really easy to be more informative. At distance, counts up to counts down. Rate, let's go ahead and replace this with a, let's do a gauge. I'm not sure what the max would be, so I'm going to go in here and make this 1E3, so 0 to 1,000. And if I run this VI, I probably need to image my RoboRio to be formatted as if it is 143288. Of course, you would use your actual team number, and hopefully this doesn't kill my internet again. So watching for that. Looks like we're good. No RoboRio targets found. That's sad. Oh, that's right. I didn't complete plugging it in, because that's when the stream died. Okay, so RoboRio plugged in. Let's rescan. You should find it via the USB port. And looks like I found it, and I've actually already imaged it to be 3288, but it's currently got a 2020 V10 image on it, and we want to give it a 2021 image. So I'm going to go ahead and, I'm not going to do this because it takes a while, and we only have a couple minutes left today. So I'm going to go ahead and close out of it, because I have seen that it is imaged as 3288. But if I click run, because this VI should be targeted at that RoboRio, it should by default allow me to go ahead and run on the target, which it is going to confirm here in a little bit. Target is already running a real-time startup application. That means it's already running robot code. Yes, I want to replace it. So preparing for download. Okay, and then it's deploying. And the first deploy takes a really long time, but part of the advantage of the run method, whether you run from main or write a quick example VI like this, or I should say test VI, is that once you've deployed all of the library stuff, the second run is much faster until you reboot, second and following. And it's much faster than actually compiling it and deploying too. Yeah, okay, I'm going to save this to my downloads folder. Yeah, I'll save this Untitled one. But successfully. I like to check this close on successful completion so it just gets out of the way once it does. Alright, so for distance it's already got minus 0.25. I'm going to try to hold this up here where you can see it in the camera. Now when I turn this knob, okay, so that looks like I don't have it wired right. And it could be I've got 0 and 1 backwards. So I'm going to swap and wire clock in as my B channel. So it's still not counting, which is annoying, especially since I've done this before and I had it work. You know what? I think clock and data are what I want, and then deep switch is the actual switch. So I'm going to completely move this around. Plug in clock and data in 0 and 1. Hey, look at that. It's counting down, and when I go the other way, it counts up. As for rate, that's not moving, probably because I'm not hitting anywhere near 1,000. Let's make it back down to 10. Okay, so it can hit 10. Let's go negative 20 to 20. And as I move this, okay, so I can hit 20. Let's make it 100, which might be extreme, but so you can see that it is jumping based on the direction that I spin the encoder, which is great. This is constantly updating, and it's updating faster than the UI can draw it. So deciding off of this would be better than trying to visually base off of it without using like a motor to steadily turn it. Turning it by my hand isn't working great. But because of that, I've also got, okay, so I've got the stop button here that actually stops the VI. We've also got a digital switch plugged in. In this case, it's just the push button on this encoder. But you can also, it represents any other physical, like limit switch or button you've got plugged in. So I can easily use those as examples as well. So again, I'm going to go down to WPI robotics library, sensors, and we're going to go switch, and we're going to open one up. And the DIO channel, it's now on 2. And you've got a limit or a counting switch. A limit would allow you to just check if it's been pressed or not. A counting switch, the idea behind that is being able to count how many times it's been pressed. In this case, I just want a limit switch. And again, I'm going to use a switch palette to do a registry set. Oops, wrong port, so Control-Z to undo. And then I'm going to give it a ref num, create constant, and let's call this button 1. If I select a regional code and hit Control-U, I get a diagram cleanup. I've already got this block happening before that block, so I don't need to pass anything over. And then on this side, I'm going to simulate reading that by going, again, to the WPI robotics library, sensors, switch, registry get, and button 1, I believe it is. Did I capitalize it? I did not. Okay. And from the switch palette, I want to get the limit value, which is just getting the current value of the limit switch. And let's create an indicator. And it gives us this green LED, which is fine. We'll go ahead and run again. Yep, save. And all of these core library things, because they already deployed once, this is going much faster the second time around. And so now, whenever I push the button, the indicator turns on. So whether this was a limit switch or an input or even a physical switch, like a toggle switch, that could be used to measure something. Using a physical limit switch to make sure to turn off the motor before it hits a physical wall or something like that. And I've also got a potentiometer here with me, but we got about 20 minutes left. No questions in chat yet, so I'll go ahead and demo that one as well. For my potentiometer, what is common on these on the back side is they have the top, bottom, and the wiper connected, so you connect 5 volts ground and the signal. I goofed that up when I did this, so these are in weird order, and as such they're weird order on here as well, but I do believe I have these in the right order to work on the LabVIEW currently. So I'm going to go ahead and plug this into analog in 0. Sensor voltage, yeah, and ground. So I'm getting 5 volts. Yeah, this one, I should have looked at the data sheet. I remember this now. I should have looked at the data sheet because this one takes 5 volts in the middle, or your voltage and your ground here in the middle, and then the wipers on the end instead. And so then again, in order to read this in begin, you open up and from the WPI robotics library, sensors, and I want a potentiometer. Advantage of the potentiometer. What happened to my slides? They're over here. They are great when you're trying to measure rotational position less than around 8 rotations. The reason I say 8 rotations is you can buy what's called 10-turn potentiometers, and that's giving just a little bit of leeway in case of going over on accident. It's for when you care about the starting position or the absolute position. So say on my arm, my robot arm that goes up and down to shoot something, I care about what position it's at, not what position it's at from turn on, ideally. You can actually work around not having a potentiometer handy by having a startup sequence. We're going to always start the arm in the down position or something like that. And it's use the devref, call a get, and this actually returns voltages. The raw is voltages 0 to 5, but I believe it scales from -1 to 1. So if it's -1, that's all the way down, and 1, it's all the way up. And I've got a tutorial on frclabviewtutorials.com under sensors, RoboRio, potentiometer on doing this with pictures of how it's wired and why it's wired a little weird. But for a quick demo, I'm going to say analog channel, create constant AI 0. I'm not going to invert it, although you could. And that's just if it moves the wrong direction. And then again, I want to set it in the registry. I'm going to give it a name. And pod is short for potentiometer, is the reason why it's called that. I'm going to call it arm angle. Oh, not receiving enough video to maintain smooth streaming. Great. This looks like it should keep going. Okay, cool. So looks like it just dropped and complained a little bit, but it should be back up. And then again, over here in what would be my teleop, I'm going to create a little bit more space and using control drag for that. And then I actually didn't want to move this wire, so I'm going to just move it back right back up. in the WPI robotics library, we're going to go sensors, potentiometer. Lost it. Sensors, potentiometer. We want to do registry get. Carry constant. Same name. Case sensitive. And then using the potentiometer palette, we're going to get normalized. And it's saying normalized because that's scaled to the -1, 1. If we open up the context help, which is control H, not control space, we can see that normalized value from 0 to 1. So then based on that, let's create an indicator. And a gauge is a really great way to visually represent this, so let's make it a gauge. And because 0 and 1 are our max, we're going to set it like that. And we can run again, which asks me to save. Yep, save all. And then currently it's reading at 0.4. I'm going to hold this up to where you can see it. Whereas it's a very short course, so I'm having to hold up the RoboVio too. As I turn this, you can see that the gauge updates as well. So, whatever position my arm's at, if I wanted to go to another one, I can use this to very nicely, very cleanly measure the position of an arm or something like that. I don't have a gyro with me, but it is useful for when trying to drive perfectly straight or when trying to turn a specific angle, say in autonomous, or which isn't exactly happening this year, but if you're trying to program a preset turn, that'd be nice. For most gyros, you just say, I want to get the angle, and then you can do processing with it. Again, PID is a great way to do it. If you're using the NavX, you want to specifically get the yaw, usually. That's your rotational position horizontally. And then I mentioned earlier sending it to the dashboard using a dashboard write. So you would want to do that if you wanted to display it on the dashboard. I'm going to do a brief overview on what PID means and how to use it. Trying to keep this short. Got 17 minutes left in the schedule I had. Again, any questions, throw them in the chat. So PID stands for proportional integral differential. The proportional is a constant that's multiplied by the error or offset. The larger this is, the faster the robot tries to adjust and approach the set point. We call this a smaller rise time. Integral is a constant multiplied by the integral of all previous errors. My camera is slightly over, so I'm going to hide my camera. That would be the wrong thing to hide. There we go, hide my camera. It's constant multiplied by integral of all previous error values. The larger this is, the less overshoot and settling time. In other words, there's less bounce. And then the differential is the derivative of all of those error states used to eliminate steady state error by reducing the offset after movement. As far as tuning is concerned, there are several standard methods available. I have tended to use the Ziegler-Nichols or manual tuning. Ziegler-Nichols, if you Google this, it's up the proportional until you get a steady oscillation, measure that oscillation, and then using that value, apply these multiples to each of your constants. I usually find that that gets me close, but manual tuning will get me closer. Conceptually, manual tuning, you raise the constant of proportional until the robot oscillates about a set point, raise the derivative until it stops bouncing, and then raise the integral until the robot turns and hits the target set point. I also oftentimes will do this in the form of raise the proportional until it is getting close, and then raise the integral until it turns and hits it exactly. You can also, using the Ziegler-Nichols, measure the constant of proportional until, raise the constant of proportional until it robot oscillates, measure that period, and apply these multiples for different methods. You can use proportional only, proportional with an integral, proportional with a derivative, or the classic. And depending on which one you want, you just throw in the constant that you had that gave you oscillations for the KU and the time of the oscillations for the TU. And I'm actually not going to demo this today, despite the fact that that was in the slides. I'm at 10 minutes. I don't think I have enough time to go into a bunch of architectures, so let me pull this off to the side and see what else we've got that I've prepped stuff on. The type data from the producer-consumer are things that I've covered in detail in the past that would possibly be interesting to talk about. However, this year's game being very different, I don't think I'm going to go into that. So if you're new to FRC this year, or if you haven't built a robot and programmed it in LabVIEW before, I encourage you to watch one of the Intro to LabVIEW tutorials that I have done in the past and recorded. If you are a little more advanced, I hope this has been helpful. Similarly, you can reach out to, there's a lot of information available online. I curate FRCLabViewTutorials.com, and that's actually, again, you can get the slides from today on, that's not doing that correctly, workshop.frclabviewtutorials.com. You can get the slides from today, as well as I will add the link to this live stream, although if you're already here, you probably don't need that. There's also the last couple of years, their slides, and supporting files, as well as links to the recordings. Team 358 and WPI themselves are very well documented. I've got lots of documents here, some written by me, some contributed, about how to do various different things, including using sensors on your dashboard. But then you also have chiefdelphi.com available. That is a forum by first team members, for first team members. I'm on there as mschaefer1, which I haven't told you how to spell at all, so I'm just going to open this and add a new slide and put that in. So if you want to get in touch with me, this is the best way to do it. Use chiefdelphi.com and private message me, or go to chiefdelphi.com, which is one word, and post a message in the general forums, and you'll be asking the questions to the broader FRC community, which is awesome. This year looks very different, and I hope that trying to adapt this class, this workshop I've been doing for the last couple of years to accommodate that has been successful. I hope that your efforts to be a game changer at home this year are successful and are effective. I wish you the best of luck. May you and your team be innovative and go be game changers.